Hello everybody, welcome to episode 14 of making an online Pokemon game in Game Maker Studio 2. Let me just delete something real quick. In this episode, we're going to be dealing with collisions as promised. Before that, we need to discuss how collisions are going to work. And before that, I want to discuss this right here. I have a new folder that I created between episodes called Terrain, and it has two assets from Pokemon Essentials. So if you see those, don't worry about those. Those I'm going to discuss next time. We're going to be adding in some nice terrain. I was going to do it this episode. That's why they're there. But I realized that collisions themselves will probably take a whole episode. So I'm going to split it up into two parts. So we need to discuss how collisions will work. Because just like with movement, with the player movement, it needs to be done on the server side. However, we want to be able to place our colliders, our little blocks of where we cannot move, in the client. So even though the server needs to know where the colliders are, we actually need to place the colliders in the client room. Because we don't want to just put collisions here and try to guess where the colliders are. And you might be asking, well then why don't we just let the client control the colliders or where the collisions are? And well, the same reason why we don't let them control their movement. I can actually probably run this quick, but again, just like with movement, how if the client controls the movement, they would be able to move however fast they want or start jumping positions because they're dictating where they're moving. With colliders, if the client can control the colliders, then they would be able to just ignore the colliders if they wanted to and essentially walk through walls. And we don't want people to be able to walk through walls whenever they want to. And by anyone, I mean like basically hackers. We don't want anyone to be able to cheat the system and control where they're moving. So to dictate that, we're going to have the server control it, but that means we need to get information out of the client's room. So the server needs to basically dip into the room of the client, extract the information out, and then use that information to control where the colliders are. And this used to be a lot harder. In fact, I have an old video from like years ago about doing the same thing in a different sense. And in there, we actually had an object that would physically call room go to, move to the room, find all the objects, and then move to the next room, find all the objects, and so on and so forth. GameMaker has since provided us with a nice function, room or get room info, I believe it's called, which will be a lot easier. So let's use that quickly. So if we go to our utility group here, we can create a script with Alt-C, and I haven't used this new GameMaker functionality before, so hopefully we get it right the first time. Unlikely, but you can hope. We're going to call this script get objects of room. I'm using a different kind of format here. I kind of like to have my generic utility functions be in the same style as GameMaker's. So that's why the split command that I created before has this kind of formatting. Because this is more of a generic function that isn't tied directly to this project. So we're going to do that. And here we're going to provide two arguments, the room and the object. And what this is basically going to do is it's going to do what I said is dip into another room, and it's going to return all of the objects of that room. We can also create another function, get room dimensions room. We don't have to create this function, but I want to because it seems like it would be more useful than just accessing it directly. So how does these both work? Well, we can get a variable called var info, and we're going to get the info of the room basically. And the function that GameMaker provides is get room get info. Okay, I was confused. I was like, what am I doing? And then we just need to pass in the room. And for the dimensions, it's pretty easy. We can just we'll return an object with an x and a y position. So info.x and y is going to be info.y. Not x and y. I think it's called width and height. My bad. And then width, height. Again, I don't know if we really need this function because we could just, instead of calling this function, call room get info. In fact, yeah, maybe that's better. Thinking about it, we'll just get the info. Well, yeah, we'll just get the info directly. If we ever need the width and height, we'll just get it from that function itself. For the objects though, this is a little more involved, so we will make this a function. So var info, we're gonna do the same thing. Var info equals room get info room. So if you middle mouse click this function here, you can actually open up the documentation for it, and it kind of shows you what it returns. So if you go to room info here, this is everything it returns, and one of those is an array of instances, as you can see, which is kind of what we want. So var instances equals info.instances, and this will return the array of them, but the instances is its own structure, so it contains all of this information, and we don't need all of this information. What we just need, well, actually we kind of do need this information, but we need to parse out this information, I should say, because we don't need every single instance. What we need is every instance that is of this type object. So I can do this by creating an array var temp inst equals a array, or we'll just make it an empty array. I was going to do array create, but we don't know how many items there are yet until we actually iterate through them. So let's iterate through all of the instances for var I equals 0, I is less than array length of instances, I plus plus. So we're going to iterate through every single instance, every single object in this room. And we're going to check, does this individual instance equal this object? And if so, we're going to add it to this array and return it. In fact, we can just return temp inst now. So the question is, how do we determine if this instance in this array is the same as this object? Well, you would think object index, but object index is a string, non-ID or non-index. So we need to do what this says, which is call asset get index to get the actual object. So we'll do that. So we'll say var o equals to asset get index, and this takes in the name, which is the object index inside of this instance. So instances I dot object index, and it's underscore index, object underscore index, and that should work. And I could probably zoom out a little bit. So we are getting the object, which is the same as like the objects here, like the actual ID, out of this. And then I can say if O equals object, so they are the same type of object, then we can say temp instances dot, and can I just do array add? Is there an array add? Concat, that might work actually. Concatenate to it temp inst O, and not O, we want instances I. And this actually is wrong. Concatenate takes two arrays and adds them together. So instead, I will have to manually add in the object to the array. So I'm going to say var n equals 0 at the very top, and then I can just say temp inst n plus plus equals n instances I. So there we go. We are checking the instance of the object, or we're checking what type of asset it is and comparing it to whatever object we passed in. If they are the same, add it to the array and return the array. So this will help us filter out all of the objects that we need. So we would be able to say, hey, give me all of the colliders within this room. And that being said, we should probably add in the collider object and create that. So under this terrain group that I created, you can just right click and create group for the terrain. Again, don't worry about these two assets. Those are for next time. We'll create a sprite for the collider as collider. I'm going to resize this to be 32 by 32. Let's edit it, and let's just make this some red color. We'll fill it with red. And if you scroll down to the layers, you should be able to change the opacity by double clicking, and we'll make the collider transparent, because we're not going to be able to see this in the end anyway, so this way we can see underneath the collider. And then we can click Alt-O to create a new object, O collider, and just give this the same sprite. Whoops, did not mean to click that. And we don't really need to do any code in here right now. And we don't need this anymore either. So if we go into our client room, we can start adding in this object collider. And again, there's no code in the collider. It's all going to be done on the server side. But I can drag this in here and add in some of these objects. Come in here, drag this out. And it doesn't matter that we're scaling it. We'll deal with that as well. We'll handle scaled objects, so this should be fine. So what our code is going to do, it's going to come into this client room and look for all of these colliders. That's what that function we just made does. It gets all of these colliders. And then we're going to get the information of those colliders in order to determine where we can and cannot move. So that should be good. If we come into our player data, we have this grid size here. We set it to 96. I'm going to change that to 32 because our objects are 32 and a lot of sprites in Pokemon Essentials are 32 pixels big anyway. So we'll change that to 32 just to make it a little more easier to see. Our player is still going to be way too big because our player, I believe, is like scaled up like 4 times or something. So we'll have to change that later, but for now, we'll just have big players. Alright, so let's, in our terrain, we'll create a script, Alt-C, to handle all the colliders. So we'll just call it collider, and we're going to make this a singleton. So we'll create a macro called collider, and it's going to be get collider. So just like we create all of our singletons, we'll create a function underscore collider, and there's going to be a constructor, and then we need our function get collider, which has a static C, is a new collider, and return C. Alright, there's our singleton made. And now what this is going to do, it's going to handle all of the collisions in the rooms. And eventually we will have more than just one client room. It'll be like a whole bunch of rooms that the players can travel through. But for now, we're just going to deal with one single room. And we'll just modify it later as we need to. So we need to come into here and we'll have a variable called data. This will store all of the data. It's going to be a DS grid. And we need to create, well, actually, that won't work because we don't know the width and the height of the grid yet. So we can actually set this to undefined for now. And we'll have to create a function called init is a function. So we can initialize all of the data. And we don't need to provide any arguments yet. Well, actually, we could. We'll provide the room. So we'll initialize and we'll provide what room the client is on. So what room do we want to get all of this data from? And for here we can say data, well, equals ds grid create. So now the question is, how do we get the width and the height of this grid? And the answer is the same function we used before. Var info equals room get info from that room. And then the x and the y is just info.x and info.y. Except we can't just pass in info.x and y because we are using grid sizes. So this x and y, and I meant width and height, not x and y. The width and height is in pixels, which is way too much information than we need because we want this in grid sizes because each grid cell is going to have a collider or not. We can't have half a collider in here, so we can't have like the collider going halfway through a cell. So we either need each cell to be movable or not movable. So how do we do that? We need to divide this by the grid size. So var width equals info.width, not x, div, and we need to say grid size. We can do the same thing for the y, or the height, I mean. You need to stop saying y, x and y, it's width and height. And then here we can pass in that width and height. So info.width is in pixels. When you divide something by grid size, you convert it from pixels to grid coordinates. So there we go, we created our grid, and now we need to populate the grid. And we'll start by populating it with all falses. So there's no colliders anywhere. So ds grid clear data, and we're going to fill it with false. So no colliders anywhere. And then we're going to iterate through all of the collider objects and determine what their x, y, width, and height are to determine where there are colliders. So first we need to get all of these objects. So we can say var objs equals, and we need to call that function we just created, which was get objects of room, get objects of room, the room we want to get the objects of, and the object is object collider. So this is going to, I wonder why that's giving me an error. Because object expects a real apparently, which is wrong. Object should not be a real. I think this should be correct. Object get index. It should be fine. Hopefully, we'll see in a minute here. But anyway, this will give us an array of all the collider objects in that room. So I can iterate through that. So for var I equals 0, I is less than array length objects, I plus plus. Also, I know I can go to feather messages and see, but I know why it's giving me an error. I just don't know why it's, well, giving me that error. Because this should be not a real, but a object, an instance object, but for some reason it thinks it's supposed to be a real, which it's not. So var o equals obj si, and what is this information? This is of type instance info, so it's going to contain all of this info right here. And what I want is the x, the y, and then the x scale and the y scale. So var delta x equals, and this is going to be the o dot x, and var delta y equals o dot y. And then we need to get the x scale and y scale. So what I can actually do is change this from delta x and delta y to x1 and y1. You'll see why in a minute. And then we'll do an x2, which is going to be x1 plus whatever the width of the object is. And how do we get the width of the object? And I don't mean the scale, I mean the actual width of the object. Well, we have to take 32 and multiply it by the scale. So o dot x scale. And it's not capitalized anywhere. Nope. This 32 is because the sprite itself is 32 pixels big. So we're going to take 32, multiply it by the scale. And I'll do the same thing for the y, which is going to be y scale, y1 plus 32 times the y scale. And this gets us the x1 position, the y1 position, so the top left corner, and the bottom right corner. And now this is all in terms of pixels again. So we need to convert from pixel coordinates to cell coordinates. In the same way, we just have to divide everything by grid size. And I could just do that right here if I wanted to. So I'll just do, for x1 and y1, I could just do div grid size, div grid size, one word, and then div grid size and div grid size. This does not need any parentheses because we're only dividing this by 30, or dividing this by grid size. We don't want to divide this by grid size again. So there we go. And now we need to take these positions and populate the grid with trues in those positions. So that's as simple as ds grid, and I believe it's add grid, or add region. And we're in grid x1, y1, x2, y2. The value is going to be true. And that should be everything. That is going to add, and that should be data, not grid. And that's going to add trues to every single cell position within this square. And that should be everything. Now we need to actually call this function and initialize it. But before that, let's actually create a function to check if a position is true or false. If a position has a collider, basically. So we'll say has collision equals a function. And it's going to take in a cell x and a cell y. So not the real world position, x and y position, but the cell position. And I'm going to say if data equals undefined, we'll return false. Just in case we never call that initialize function, we'll check that. We'll say if cx is less than 0 or cx is greater than or equal to, and we'll say grid or ds grid width of data. Then we'll return false. Want to copy and paste that again, and these need another brace. This one's going to be for the height. So if cy is greater than that or less than 0, return false. Otherwise, I can just return data, and you can do square bracket hashtag cxcy. That's if you don't know, this hashtag isn't a special accessor for DS grids, so I don't have to do like DS grid get or anything like that. And this will be able to tell us if there's a collision at any specific position. So back to the server now. Like I said, we need to go and deal with the collisions, which we'll actually do that. I believe it's under the player data. I think this is where we're doing our movement. So if we scroll down to the update server, this is where we actually update on the server side the position of the player. And so we're checking basically if we are moving and we're ready to move, then move. But we need to add another condition here to check, can we move into this position? So var can move equals, and that's a bad name actually, has collider. So is there a collider in the position we are trying to move to? And for this we can do collider dot has collision, and this will take in the x and y position. So this is where we want to move to, so it's going to be grid position dot x, that's our current grid position, plus delta x, so where we want to move, and then this will be for the y position. And then here we can say if in position and not has collider. So only move if we are ready to move and there's no collision where we're trying to move to. That should be good. And we need to go into our server now. So network, actually we'll go to the object network controller, and we're going to initialize the colliders by going to down here, and we only need to do this on the server side. So at the very bottom we'll just say collider.init, and I believe we need to pass in the room still here, so we'll say the client room. Alright, that was a lot, but hopefully now if I run the game and I run the client, you'll see we move. We did start off in the kind of halfway in the middle of a collider, but that should be fine. If I move to the right, I can no longer move into the red zone, and I can no longer move up either. If I move down, I can't move down. You can see there's a little bit of, I'm like inside of the collider halfway. That's because the player is way bigger than it should be right now, because like I said, we're scaled up by like 2 or 3 times the normal size of the sprite. So we'll fix that later. But for now, collisions are working. If we go back in, we can probably take another look at this. So again, we got our collider here. This has a variable for data. This will have all of the collisions, all these cells that we cannot move to. We initialize by first getting the size of the room, creating the grid for that position, for that room, filling it with false so there's no colliders anywhere at first, getting all of the colliders in the room, which it's still showing with an error, even though clearly it just worked. We're going to iterate through all of the colliders, get its X, Y, width, and height position, and then fill up the grid with trues depending on where that collider is. And then here we just check if there's a collision. Alright, so one more thing we can do, and this has to do with the fact that when I run the program, we are halfway in the middle of a collider. So let me come and train again. We'll just create a sprite for sPlayer start. This will just be a proof of concept. You can skip this if you want, but I recommend doing it anyway. Well, it's kind of important. We'll make it 32 by 32. And I'm just going to draw a circle. And man, this is small. So yep, just draw a circle. Doesn't really matter. You can give it make it a little fancier if you want. Fill it, make it thicker. There's probably a much easier way to do what I'm doing right now, but that should be fine. Anyway, I'm going to center it. Well, I won't center it actually. Yeah, don't center it. Keep it top left. And let's create an object now for the oPlayer start. And we'll set this to be that sprite. So under terrain, sPlayer start. Again, does not need any code at all. And we can go into our client room and drag this in anywhere you want. Doesn't really matter. And then if I come back into my server here, if you scroll down to down in the server, we have this line right here where it says var p is, we're going to make a player and we're making it at the position 4-4. That was just a hard-coded number that we created because we were just trying to, basically we were just adding something in. So we don't want to just hard-code numbers in like this because then what if we want to change it later and all that. So we're going to use this object we just created and we'll use it to determine where our position is or should start at. So this should be really easy. So var I inst equals, and we'll say get objects of room, that first function we created under the client room. And we're going to search for the object oPlayer start. And here we'll say var xx equals inst 0 because this is an array, so we need the first instance that we find, and dot x, and then var yy equals inst 0 dot y, and here we should be able to just do xx yy, and it would probably be better to check if these are actually valid positions. So I could do that simply by saying if inst or array length inst equals 0, then we'll do 0. So if you don't know what this is a ternary operator. So it's basically saying if the array length is 0, then return 0. But if there's at least one element in this array, then we're going to return the first element. If you don't know about ternary operators, I suggest learning about them. They're very helpful. So I'll do the same thing for the y. And so this will just basically say if we didn't add this player start object into the room, then we're just going to start off at 0, 0. But there should be. So let's run this and run the client, and well, yeah, that didn't work, did it? That's because we need to divide it by the grid size. Because this is in terms of pixels, we need it in terms of grid size. Div grid size, div grid size. So we're going to divide the x and the y by grid size. And run this again. Run the client. And there we go. Now we will start wherever the that object is. But that is going to do it for this time, this episode. Next time, like I said, we are going to be dealing with adding in some more background elements to make everything look nicer. This will be a pretty easy video. There's not going to be much coding at all, I don't think. So it's just going to be adding in these sprites here and like adding in trees and some grass to make this look nice. Anyway, that is going to do it for this episode. So until next time, I'll see you guys later.